Hello, welcome to the second lesson of our fourth unit, Graphing Quadratics, in our grade 10 academic math class. Today we're going to take all the incredible amounts of stuff that we learned in our first lesson and we are going to consolidate it a little bit. That's going to be sort of the goal of the day today, or the goal of the lesson today, is to consolidate the things that we were doing in the last lesson, put some more terminology onto the table, and then kind of just do a little bit more of that, the graphing from vertex form. So let's begin. At the top we have a quadratic relation in the vertex form, which is what you see here. And what I've done is I've written down sort of a description of what each component of vertex form tells you about how the quadratic is going to look. So let's start with this guy over here. So this guy is basically saying the a value's sign. So never mind the a itself, just focus on the sign. A positive a value tells you that your parabola is going to be opening up. A negative a value tells you that your parabola is going to be opening down. And what I've written under there is the specific phrasing that we are going to be using throughout this unit. And this deals specifically with the negative. If you have a negative in front of your a value, the phrasing that we use to describe that is a vertical reflection across the x-axis. So this is something that you're going to want to utilize and hopefully memorize over the course of the unit. Once we've looked at the sign of the a value and determined whatever it tells us, then we can look to the a value itself. Now the a value itself, it depends on how big or small this value is. So if the a value is larger than 1, meaning anything bigger than 1, 1.00001, all the way up to the largest number that you could imagine, we call that a vertical expansion by a factor of whatever a happens to be. The other option is that if our a value is between 1 and 0, which would make it a proper fraction, like 1/2 or 3/5 or something like that. And in those cases, we say that it is a vertical compression by a factor of whatever a happens to be. Now these two values here at the front, the positive and negative, and then the a value itself, they sort of dictate the shape of our parabola, while h and k dictate where our vertex is, basically where on our coordinate plane is our parabola going to have its vertex. The h component is the x component of our vertex, and it moves left and right. So the phrasing that we're going to use to describe that is horizontal translation, left or right, depending on the value, h units. Similar to that, our k value, it tells us the up and down place where our vertex is going to end up. And the way that we describe that is a vertical translation, up or down by k units. So we're going to get a chance to practice these. Hopefully you've got this copied down already, and I want to draw your attention to these 4 boxes here. It goes over very specifically what we just talked about, how the sign in front, so this is the reflection piece, how right here, reflection, how the sign out front of the a value tells you whether or not something is vertically reflected across the x-axis. And I have to stress, it's when it is negative that it is a vertical reflection across the x-axis, which is sort of a fancy way of saying our parabola is going to open down. Next we look at the a value, and the a value, if it's larger than 1, we call that a vertical expansion by a factor of a. And if the a value is between 0 and 1, that's sort of what this little fancy bit is here, which is like a proper fraction, so 1/2 or 3/4 or whatever, we call that a vertical compression by a factor of a. And as I said before, reflections and stretches, they change or dictate the shape of our parabola, whereas number 3, translations, both horizontal and vertical, they tell you where your vertex is going to be. So the left and right movement of your vertex and the up and down movement of your vertex. So the phrasing we use for that, horizontal, which is the one inside the brackets, as we show over here with the h, we call that a horizontal translation to the right h number of units, whatever it is, 5 or 10 or 6 or whatever. And the k value, which is the constant value at the end, this is described as a vertical translation up or down k units depending on it. If k is positive, it's going up. If k is negative, it's being translated down. So this is the summary of the phrasing, the words that we use to describe these transformations. And this little piece here talks about the order in which you would apply these transformations, since it stands to reason that if you apply the transformations in a different order, in the same way that if you do bed mass in a different order, you end up with different answers. So the proper way to apply these transformations is reflections and stretches first, followed by translations. This very much follows the order presented in bed mass, and I like this little sort of piece of advice right here on the bottom. You can't go wrong if you describe the transformations as they occur from left to right. So if we look back up here, the first thing we would describe are the vertical reflections across the x-axis, followed by vertical expansions or compressions, followed by horizontal translations and vertical translations. Tackle them as they show up left to right, and you will have them in the right order for sure. Okay, so hopefully you've got that down. Let's do a little bit of work. So here's what we're going to do with each example. We are going to describe the transformations relative to the graph of y equals x squared in the correct order, i.e. as they show up from left to right. Then we are going to graph the quadratic using the vertex and the plot pattern in the direction of opening. And then we're going to label the vertex, the axis of symmetry, and any x or y intercepts that go through integers. Okay, so let's tackle a few of these. Actually, let's tackle two of them. We have y equals 2 bracket x minus 3 all squared minus 2. So we have three transformations going on here, and we're going to tackle them left to right. So what I want to point out here is the sign in front of this 2 right here. This is a positive 2. But because our parent function, so our parent function is y equals x squared, which looks like this, very-ish, y equals x squared already opens up. So if the parabola that we're describing here also opens up, we don't need to make a note of it. We don't need to state it. If it opens up, no problem. So we're going to skip right over because there is no vertical reflection. You don't need to say it. Next, we're going to look at the 2. So this one is a vertical something or other. So we're going to call this vertical. Now the question is this an expansion or a compression? Well, 2 is larger than 1, so we are going to call this a vertical expansion. And the rest of the phrasing is by a factor of 2. And again, we would put in there whatever the a value happens to be. In this case, happens to be 2, no problem. Okay, let's look at the second transformation. Now we are inside the bracket, and if we remember, this is a horizontal translation. Oops, that's not how you spell it. Horizontal translation. And our horizontal translation moves us a certain number of units, so in this case it's going to be 3 units. And now the question is which direction. Now this looks like a negative 3, but if we recall, this is actually x minus positive 3, all being squared. So that's a plus 3 that's actually in there. That tells us that we are going to be going to the right. Which makes sense. If we look at the graph down here, we'd be looking at values being shifted from the vertex over in this direction to the right, since these are the positive values that tick off this way. So that makes sense. It is a horizontal translation, 3 units to the right. And let's look at our last transformation. So it's that minus 2 right there at the end. It's a constant. So the one at the end, as we recall, is a vertical translation. And it is going to be a certain number of units. In this case, it's going to be 2 units. And that value we take at face value. So if it is a negative 2, we are going to be vertically translating 2 units down. Makes sense so far? Okay, so let's look back at the actual vertex form version of our quadratic relation that we have, and let's determine what the vertex is. So I'm going to get you guys to fill in vertex, direction of opening, and the equation of the axis of symmetry. So pause the video here, fill it in, and let's see how you do when you come back. Okay, you're back. Hopefully you filled it out. So our vertex is going to be 3, negative 2. 3 because that looks like a negative 3 in the bracket, but it is actually minus a positive 3. Our direction of opening is going to be up since our A value is positive, and the equation of the axis of symmetry is x equals h, which in this particular question is going to be 3. And now we graph. So let's get 3, negative 2 onto our graph. Let's change up our colors a bit here. So we've got 1, 2, 3, negative 2. There we go. So there is our vertex. Our parabola is going to be opening up, as we know. The other thing that we want to now go over is the plot pattern. So I'm going to do that. I'm just going to do it over here on the side. So if you recall, this was 1, 4, and 9 that we were using. And again, if you recall, that was plus or minus out 1 from the vertex, plus or minus out 2 from the vertex, and plus or minus out 3 from the vertex. These ones are the ones that tell us how many up we go. These are the ones that tell us how much left and right from the vertex we go. So there we are, we have 1, 4, 9. This is being amplified by our A value, and our A value was 2 for this particular question. So from our vertex, we're going to go out 1, up 2, out 2, up 8, and out 3, up 18. Like I said, I find that really helpful to have on the side there. I highly encourage you to do the same until you have this thing under control. So there's our vertex. Out 1, up 2, out 1, up 2, back to the vertex, out 2, up 8, so that's 2, 4, 6, 8, up here, 8, and I'm definitely not going to fit 18 on there. So that's all I'm going to get on this particular graph. I'm now going to sketch through my points. That's terrible. Sketch through my points as best I can with a curve. Still not great, but better. Get some arrows on the end. I'm going to label some points now. So my vertex was 3, negative 2. My x-intercept here, they both happen to go through integers, so that's going to be 4, 0, and over here we have 2, 0. That's him over there. There are no y-intercepts in this one, so let's label the equation. Y equals 2 x minus 3 all squared minus 2. I think that's what it was. 2, yep, that looks good. And now we're going to dot on our axis of symmetry. So again, that's going to be dotted through our vertex all the way, top to bottom, through the vertex. And when we get down to the bottom, we're going to label that x equals 3. And there you go. We have our first graph completed. This video is getting a little long, so I'm going to pause it, or I'm going to stop it here. We'll come back for part 2 so that we can finish up this second graph and move on to the homework.